My name is Kenneth. You have been looking at my first slide for a while. You probably guessed that I work for a company called Realm. I've tried to write it so many times on the first slide, so I really don't have to say much more about it. I have just one slide about the company, but except that I will be talking mainly about C++. I'm not really an Android developer. I do C++ and C. How many of you are C++ developers? A few. How many of you have actually tried to program in C++? That was maybe a better question. Great. Long time ago. Then I haven't been to Italy for 20 years. I'm from Denmark, in Copenhagen, Denmark, and I haven't been here for 20 years. It actually, this summer, it's 20 years ago last time. And I spent a month in Como. As a PhD student, I was at a summer school. And you'll actually see the example I'm going to present today is based on that summer school. So you're kind of linked to northern Italy somehow. What I will try to cover is that when you go home, you should think that Android development is not just in Java, and you're so eager that you want to brush up on your C++ and start working on Android and C++ at the same time. One of the things that you can use native code, C++ and C code, is that you can actually reuse. There's a huge amount of source code out there written in C, especially C, but also in C++, that you can reuse. Since most of the Linux and BSD operating systems are mainly based on C, there's a huge legacy of code you can use. There's also a lot of the old Microsoft world was written in C and to some extent in C++, all the old applications, and there will also be a lot of libraries and utilities you want to port maybe, so you can use it for that. And maybe you will also learn a few tricks on how to do it actually, because using the Java native interface, or JNI, isn't that simple, because you're actually working in two different worlds, in two different languages, with two different tool sets. So it's really a mess, and you'll enjoy it, believe me. I'll just tell you a little bit about me in a second and about the company I work for. Then I will actually do a simple example, and it's on GitHub, so you can actually look up the source code if you want to try it. It is how you estimate pi using a Monte Carlo technique, which is kind of used in statistical mechanics a lot of times. Then I will actually go through how you use the Java native interface and some of the things that are specific for Android. You cannot just, there's a lot of textbooks on Java native interface. Part of them are wrong and does not apply to Android. So you want to take a look here and learn a few tricks, I guess. Just about me. As I said, I am from Denmark. I live in Copenhagen, or just outside Copenhagen. I'm a chemist by education, geek by nature. You can see this is my first chemistry set I got when I was 12. This is my first computer. And you can see that I've been using, when I started using computers, I turned into Unix when I started at university. This is my first child, and this is the second child. And I know that Italy is a football country, just like Denmark is. I know I might have been doing something wrong in bringing up my son. He's a footballer, but he's a Chelsea fan. I'm sorry. It's really hard. Just to sum up, what is Realm? Realm is a fairly new started company. We came out of Y Combinator, which is really tough to get in. Anyway, we just got a lot of money, $20 million, on our bank account last month. So we are fairly well funded. I'll try to speak louder, try to remember to speak louder. We are kind of a distributed company these days. We have very large 8 developers, which is large in our company, office in Copenhagen. And we also have one in San Francisco downtown. We also have developers in all over the world, basically. We don't have any in Africa. We don't have anyone in Italy at the moment. But you can see that we are hiring people, so you are welcome to apply if you want to. So we can start up in Italy as well. Realm is basically a new database. You know that if you look at Android and iOS on the iPhone, they have one thing in common. That is SQLite. So they have the same database bundle. So we decided to write a new one, because it's fun to have at least some competition. So we have a bundle database, so we have to make people into installing a new one. It's written in C++. It's very cross-platform, so you can actually use the same data model and the same data files across the platforms. It's a full ACID compliant. It's super fast and all that, I have to say. That's line there with fast and low footprint. That is the marketing department, I think. But it's actually true. Our iOS binding and our Android binding are open sourced, and our core is currently closed source. But we plan to open source it soon, which we have been saying for the last 3 years. Soon. It just has to be bug-free and feature complete, and you know, that kind of stuff. Seriously, we are going to release it soon. But we are hiring, and you should look us up. Anyway, the Java native interface. The whole idea is that you can use C. In the beginning it was C, but you can also use C++ in your Java applications or your Android applications. The good thing about that is you don't have to do something just-in-time compilation or anything, because you compile your C or C++ code to the real machine code instructions. Once and for all. It's done. It's there. So that, in principle, that makes it much faster. I know that some of the newer tricks with Dalvik and especially Art, they kind of do all this bytecode, and then at some point they figure out, we better do some real just-in-time compilation and then run with that after a while. But when you do C and C++, you don't make that decision, you just do that at compile time, that decision, so to speak. So that makes it easier. You also have access to some of the system calls, like mmap, memory mapping, which is really cool. Memory mapping files means that you can actually access very large files, even in Android. You can also allocate more memory than you can within the virtual machine, because you can basically just allocate as much memory there is in your phone. So if you have 2 gigabytes of memory in your phone, you can allocate 2 gigabytes of memory with no problem. Of course, you can also do a lot of OpenGL programming, which is what people are using it for most of the time. I never tried that. Since I'm not a game developer, I'm not an Android developer, I'm just a C++ developer, so I tend to do memory map stuff into my thing, and do all the memory manipulation manually, which means I can actually access a lot more memory. That is one of the good things. The bad things about that is that when you can allocate and you don't have a garbage collector. You actually have to free memory when you don't need it anymore, and you forget that, you have a memory leak. And if you do it wrong, you end up crashing your application, and you do that a lot in the beginning. One of the real problems is that you want to debug that. But since you're in 2 different worlds, you are in the bytecode world and in the, should you say, the real close to hardware, the real hardware mode, the machine code instructions. You're in 2 different worlds, you're 2 different languages, C++ and Java. So if you have some Java code and it's called some C++ code, your debugger has to know that you're actually changing to a different language, and that is not going to happen. That is one of the real disadvantages, that you have the debugging is really, really hard. Then I'm an old Linux user. How many of you have been using Linux before? Some of you, have you developed C++ or C for that? Some of you? Linux comes with the GNU C library, which is a huge, huge library, and has all sort of nice things. The Android C library isn't as large. Of course, it's just a minimum, and it's very different. So when I come from my doing C and C++ development on Linux, it was a very different world, because it was a completely different C library I could call. Some of the standard C functions are there, malloc, for example, or fopen, but there's a lot I'm missing. Doing these calls from Java to C or C++ is fairly expensive. It doesn't take that much time, but you have to set up, and you're actually going to call outside the JVM, so it's a little bit expensive. It is, though, much more expensive to do a call from C++ to Java to execute Java code, because then you have to get into the JVM and do something, and you don't want to try that, because it's very expensive. It takes a lot of time. So that would actually slow down your application if you start doing that. In the NDK, the native development kit from Google, they provide header files and so on for some libraries. But actually, when you look at an Android phone, there's a huge number of libraries installed. OpenSSL is installed there. They have a standard OpenSSL library installed. But you cannot call that directly from your C++ code. So you have to do really strange tricks to do that, because then you have to, instead of just linking, as you normally would do, you have to manually say, I want to load this library. Within my C program, I actually do a dynamic link call, this DL open call, for example, to say, I want to load this library, this shared object file, which normally the linker does for me, but since it's not supported. And there's also the ICU, this one, if you're using Unicode, you want real Unicode support, so you can do sorting in very strange languages outside Europe, basically. Also, if you want, we have that in Danish, we have special characters, we have more characters than they have in the English alphabet, and I think Italy is the same. Most European languages actually is a superset of the English alphabet. If you want to do searches in that and sorting, the result is not what you expect them to be always. Because if you're sorting as an English alphabet, you get strange results for some of your letters. You probably know that. So if you want to do that in your C++ code, you can use the ICU library. There's a library for that. But it's not directly supported, so you have to manually load that. And it's just a lot of extra code you have to put into your application because of that. That is, I'm trying to say that using SSL, OpenSSL in your application then is a little bit cumbersome. It can be done, but it's not that easy. Besides that, if you want to do POSIX threads, the Bionic C library support most of it. So if you are very used to using POSIX threads and all the function calls you can get in that library, they're not all supported, but most of them are. For most common use cases, it is. Realm, as I work for, we are of course using a lot of C++ code and calling that from Java. I just listed a few others. There's a game engine called Ant Engine. The ImageMagick, if you're a Linux user, you probably used ImageMagick at some point, just by saying convert on the command line, convert from one image type to another, which is ImageMagick. You probably use that. But there is actually an Android port for that, and since it's a C library, there's a call to that C library. LevelDB, which is a database, there's also an Android edition of that database. and this support vector machines, which is a machine learning library written in C. There's also an Android port, so you can actually code that from your Java application. But of course, they have a lot of C++ code. Just to give you a few open source examples of people using this NDK stuff. Just to get you started, if you want to estimate pi, you can use, if you're playing Dart, you know that you throw the arrow and you hit if you're really good, you actually hit the disk you're supposed to, and sometimes you just miss. Since I'm not a very good Dart player, I probably miss half of the time. Anyway, but you can actually estimate pi by playing Dart. And I'm pretty sure that the cameraman hates me at the moment because there's a blur there. I'll just move over here. But you can actually estimate pi using this small Monte Carlo. This is called a Monte Carlo simulation. If you're studying statistical thermodynamics, which I did, this is page 2 on any textbook on that subject, how you do that. So that is, you draw a lot of random numbers. If they're within the circle, you count that, and all the misses you don't count, and you use that for estimating pi. This is not a very accurate, it's a very slow way of estimating pi, I have to say. But it was just to give you, I have to come up with some kind of example, so we could try it out. So you can go to GitHub and find my Android CalcPy thing. And this is actually the most non-trivial Android app I ever wrote. It has a drop-down, and when you choose a language, Java or C++, it will actually do the estimate. This is actually the most fancy Android app I ever tried to make. And I went to a talk before lunch about branding, and you are not supposed to put your logo on top of your apps and so on. And I didn't do that, so I was branding it correctly. There is a pure Java implementation, a C++ implementation, and a mixture. And you can look it up if you want to try it and see what it is. It's basically just a number of classes. There's a random number generator class and a class for doing the estimate using the random numbers. So it's a pretty simple one. And all the methods they have, the random number generator, they can return a number between 0 and 1, random distributed. And there's a method on the pi class that can do the estimate, and it just loops through and draw a number of numbers and try to estimate it as good as possible. So that's very simple. And just if in case you can't remember the value of pi, I wrote some of the digits there. It's actually very simple to work on using NDK, the native development kit. If you want to add C++ or C files into your Android project, and you're using Android Studio and Gradle, how many are using Eclipse these days? Actually, a few. Okay. Then we should still support Eclipse, I guess. That is actually a huge discussion. Once a week at where I work, the Android group where I work, we are 3 persons, and we are supposed to support everything and so on. So we're still supporting Eclipse. So that's why when we meet Android users, we normally ask them how many. There's still a few Eclipse users, so we will still kind of do that. But if you're using Gradle and Android Studio, it's pretty simple. In your app, you add your in the source main, you add a new folder called JNI and source, and you just put all your C or C++ files in there, basically. Simple as that. And then you install the NDK, and you add that to your local .property files. simple as that. And then you add a section in your Gradle, build.gradle. And then you will notice when you start building, it will say, this feature is deprecated. We will release something new soon. Now they've been saying that for quite some time. And soon is not soon going to happen, I believe, now. The latest of the Android NDK plugin for, or the latest Android plugin for Gradle, there was no news on the NDK part. So that is still very hard to do. And it's still deprecated. You will get that warning every time you build. And the problem is even worse, since you cannot do very much. You can add C flags, and you can tell which standard template library you want to use, which is a C++ thing. But you cannot really say anything about linker flags or any more advanced things. So it's really, you're very much limited. You can see here that I create a module that called calcpy, and I set some flags for my C compiler, and I actually link with this standard template library implementation, basically, and that's more or less what I can say in there. If you want to do more advanced stuff, you have to write your own Gradle scripts. And what we do at Realm, we have an good old makefile that actually compiles all our C++ code. And that we actually basically just calls that from Gradle, because that's just simpler. It's really, really hard. But if you want to know a non-trivial example of how you do that, you can actually look up Realm on GitHub and see how we do our Gradle stuff, because we organize it very differently. Because we have to do a lot of optimizations, and I'll mention some of them in the end. Okay. But if you do use this NDK section in your Gradle file, Gradle build file, it will actually automatically, just these few lines are just this NDK, curly bracket, blah, 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 and I put my source files into this GNI/source folder, and nothing else. It will actually automatically build for all these supported architectures every time I do my app. How many of you have a MIPS-based Android device? Okay, we build every time for MIPS and MIPS 64-bit, because that is the standard. As you can see, it builds for all kind of architectures. The good thing is when the Android installer, it packages it all into the APK package file, and when you download that from the Play Store, of course the package is huge because you have all the shared objects, you have all your C++ stuff in there, but it will actually only install for the relevant architecture. So you might have a very big file, but the application is actually much smaller because you actually get rid of all the ARM and ARMv7 and so on if you have a MIPS device. We will not install that. That's the good news. But it will actually maintain all of this. In order to use your C++ or C library, you have to add a line somewhere. You can do that on your main activities on create. So it's just in the beginning. It loads your shared object. So it's just system load library. As simple as that. And it will actually find the right shared object, loads that into memory, and that's it, basically. Simple as that. You just have to remember this name, calcpy here. In my example, it has to be the same as you have in your Gradle file, of course. Otherwise, it will not work. Okay, how do I then call a C++ function? Yeah, first of all, Java has a keyword called native. So you have to put that into your signature. Of course, in order to use something in Java, you have to have a method there, and implement a method somewhere in some class. And if you want to say to the Java compiler that it's a C++ function. You do that by saying native in the signature. Then, of course, there's no implementation. You just say, find it somewhere else, basically. That's what you're saying. And you can see I have an example down here, native, and then I have a native create method, which takes some arguments. Another thing is that in C++ and C, we work with pointers. Not just as in Java, where we have all these references, but we actually work on pointers. That is memory locations. We have physical memory locations. They're probably not physical. They're virtual memory locations. But we have pointers. We have to store them somewhere in our Java application or our Android application. So we use a long for that. The trick with long is that in Java, long is always 64-bit, a 64-bit integer, always, by definition. While in C++, a long depends on the architecture. So if you're working on a 32-bit architecture, a long in C++ long is 32-bit. But a pointer is 64-bit. So use a Java long, I have to say, a Java long to store your pointers in. Then it will work. You will see later that now and then you will actually get negative values. So you just don't think about what the value is, but you just use the long to store your pointers in. That is the trick. That's the trick number one. So that's what we're doing here. You can see you can also return a double. For example, you have a method here called native estimate, which returns something. I also have here, this one, create natives, is actually the constructor, the C++ constructor. It will call the C++ constructor in the end. And I store that, and I use that as an argument when I'm calling. So it can actually figure out, OK, when he's calling, this is the object he's using. So the native pointer, native PTR, is actually the class reference, you can say. That is the class in C++. OK, but we have to have some header files. And the Java development kit comes with a tool called Java H, which actually can take from the .class files. When you compile build your app, all your Java files, you get class files. And in those class files, you still have these methods with native on the signature. And the thing is that the Java H actually takes all these, runs through all your .class files, and figure out, OK, this method here is a native method. And then it can actually generate the proper header file for it. Because it has to convert the type. For example, the Java long is not the same as a C long, or C++ long. As I said, that a C++ long on a 32-bit platform is a 32-bit long and not a 64-bit long. So there has to be some kind of type conversion there. So it has to keep track of that. So there's a utility to do that. And since you have to go through all your classes, and I can't remember all that every time, so I always write up a small script. And then I figure out if there's a class file in my Android app that doesn't have a native call. It always is 13 lines long. Then it doesn't have, because there's some header in the end saying, you shouldn't change this manually, you should use the header H utility. And there's some in the end saying, this is still a JNI-based file. So when you count that, it actually is 13 lines long. And that means if you have a header file after generating, that is 13 lines long. It means that has no native calls in. And that's why I always have this line in the end. I find all the files that has 13 lines and remove them, because I don't need them. That's just because that might be a little bit strange. As I said, that we have these types. We have to map Java types to C and C++ types. And you can see here the long in Java became the J long, because long is something else in C, so we have to have a special one called J long there. And in general, there's the string become the J string, and the arrays become another data structure called long arrays. And another thing is that if you want to take a date object, a Java date object, C++ doesn't have anything like that. So I would suggest that you actually convert it to a long. You can ask for the timestamp, the number of milliseconds. Basically, a date in Java is the number of milliseconds after January 1st, 1970, as I recall. To just convert it to that and use that value instead. That's much simpler, because you really don't want to look up the class date in your C++ code, because that takes a long time, and convert that, and just convert that in Java to a long and send that as an argument to your C++ code. That just makes it much faster. I have here a small example of this native estimate. You can see that this Java H utility generates a really nice header. See, it has the whole package name, and it has these arguments there. This native pointer that comes in, this is now a JLong, because it's a Java long. So I have to convert that into a proper C++ pointer. So I have to cast that, beautiful cast there, reinterpret cast. So now I have my proper cast, and then I can actually just call the methods in C++. And since that returns a double, I can return a double, and C and C++, when you return that to Java, it will actually automatically convert that into a Java double. Java double is actually the same as a C++ double. It's the same IEEE standard. So you have to do these kind of tricks. Very often what I do, because I have to do this conversion between the native pointer to the proper C++, I would normally write a small macro in C++. And macros is, if you never tried programming in C++ or C, you don't know what a macro is, but that is just a search and replacement thing which is actually done before you actually compile the code. And you can do very ugly and interesting stuff in there. But this one is very simple. It was just, every time I just say P of something, it would actually just rewrite it to that before it compiles. So I can just, instead of writing this very long line, I would just say pi or P of native pointer, just because it's simpler to write, and if I have to write that 10 times a day, it's just simpler. Working with arrays, well, you have to copy the values of your array from the virtual machine's memory, from the heap, to your C and C++ memory. And that is not trivial. You have to get the length of your array, then you have to get the elements, and after you use them, you have to remember to free the copy of all your values. Because if you don't do that, if you miss this last line here, you have a memory leak in your Android app. And believe me, I had tried that, and that was really hard to find. It took me a day to find that leak once I had that. So you have to remember to release that. And that is actually, I've seen that in some textbook on JNI, that they actually forget that line. So just be warned that remember to free your stuff in C++. If you want to create a Java array in C++, it's very simple. You can, for example, here I create a byte array of a certain length, fill it with data, copying data to just to a byte array. Then I have a temporary buffer for that, and I have to remember to free my memory in C++. Always remember that. And then I can return my array. I said it twice during this slide. Remember to free your memory in C++. Otherwise, you have a memory leak. Another thing is that strings are troublemakers in Java and of course, in Android. The problem is that Java strings are modified UTF-8 strings. You can also have UTF-16 strings, which are perfectly fine. But if you are using, often you have modified UTF-8. And the problem is that a lot of C and C++ libraries, they actually assume standard, plain UTF-8 strings. So you have to convert your Java modified UTF-8 strings to plain strings, UTF-8 strings. Especially if you want to share data between platforms. That's really important. If you want to share with an iPhone, or a Linux machine, or anything else, basically, you have to convert. This is a Java problem in general. If you want to copy, for example, here I actually creating a new string. On this one, I'm creating a Java string. You can see that I can do a new string there. And you have to do a lot of things where you actually calculate the size and so on. If you want to copy a Java string to a C++, you have to get the string and remember to release it afterwards. When you are copying a string, you actually always copy value, and then you have your data, and you have to free the copy always manually. I know that in Realm we have a huge library for converting modified UTF-8. I know that the Chromium Browser, what it does is that I actually looked it up in the source code because I was thinking, why do we have to write all this stuff? Why it's not just working? And I figured out that what they're doing in Chromium, they actually copy all their strings, all their Java strings, to UTF-8 strings. When you have them as UTF-S strings, they can easily convert them to UTF-8 strings. So they actually convert it twice every time they have a string. And LevelDB is doing a similar thing, but I think they do it on the Java side instead. So every time before they do a C++ call, they actually convert the Java string to a UTF-8 string before doing the call, just to be sure. So strings are troublemakers. Maybe you should just kind of get rid of strings. One thing is that C++ code, not C code, but C++ code can throw exceptions. And we like exceptions. The problem is that if you don't catch exceptions in the C++ layer, in your C++ code, it will end up looking like something like this in your log file in your phone. And as you can see, it just dumped registers, and you have no clue what that means. So really, always catch exception in C++. Because at some point, something will throw an exception, and if you don't catch it, you will get strange crashes. And they're really hard to read, because I have no clue what this means, that these registers and memory locations and so on. You have to remember that in the C++ standard library, the new operator, which actually creates memory, just allocates memory, can actually throw a bad alloc, for example, meaning I'm out of memory, basically. So if it's out of memory, it will actually throw an exception, and you will see a crash like that. So what you should do is that you should always catch your exceptions and throw them as a Java exception, because they look much nicer in your crash report. You can actually get an idea what it is then. How do you do that? Okay. Of course, in C++, you have a try-catch functionality, just like in any language you have exceptions. So you try something and catch, and then in the catch part, first you look up the class you want, and finding a Java class from C++ is expensive. But we are now in a situation where our app is crashing, And I'm pretty sure that the user doesn't care if it takes 10 milliseconds more to crash or not. So it's fine. In that situation, it's perfectly all right to be slow. So I find the class, and in this example, I'm just using the runtime exception. And then I generate a message. And then I call a method called throwNew, and it does not throw an exception. It just tells the JVM that an exception has been thrown. It sets a flag. There's something in the native code that wants to throw an exception. Nothing else. It just sets a flag saying someone, and then continues. The C++ code continues. No problem. And you can ignore it. And you can also, if you recover from it, you can also say, clear that flag. I didn't mean it. So throwNew in this C++ layer doesn't throw an exception. The code continues. That's very important. And then I actually have to clean up because I just allocated a class reference and I want to delete that, so I don't have a memory leak. Even though my app is going to crash maybe, I don't want a memory leak. That's just by principle. Because I might clear later on that I really didn't mean to throw an exception. And then when the last C++ code is executed and returns to the GNI, the GNI will look and say, did the native code wants to throw an exception? Yes, the flag was there. And then a Java exception is thrown. And at that point it's thrown only. So you can execute tons of lines after you start throwing a Java exception. You might want to close things and do nice things in the UI or erase files, remove all your temporary files or whatever. Remove all the traces of you made a mistake or something. Who knows? Anyway, so now that you throw a proper exception, you get a much nicer thing. You can actually read it and you get a stack trace and nothing strange with strange registers and anything. You also want to do logging. And this is one of the differences between Java and Android. In Android, you have to use the Android log, of course. And there is a C function for that. It's called __Android_log_print. You type that every time. And you want to add the log library, so link with that. Very often I simplify it a little bit. Instead of writing __Android_log_print, I define a macro just called log, because it's much simpler. And it can take a valuable number of arguments. One of the things is that very often in C++ code you use size t for saying size, for iterators and so on. And since size t depends on the bit width of your architecture, so it's a 32-bit architecture, size t is 32-bit, and so on. And if I had something else, it would have a different thing. So you really want to cast to a 64-bit integer before you print out. Otherwise, you get a lot of warnings for some architectures. Because if you're trying to log to on a 32-bit architecture with a 64-bit value, you will get warnings, and of course, the other way around, it was the opposite. So you get, just to get rid of all your warnings in your build logs, you cast all the time. That's a good trick, by the way. So that was logging. And I use logging a lot for tracing. Since debugging is really hard, it's just easier just to add a lot of log messages. And so I can just trace what did it call at what time. So I normally have something called enter or enter pointer. Enter pointer just take a native pointer and print that out. So very often I want to see if it's null or not null, basically. Or if it's changed between two calls, because if it's changed between two calls, there's definitely something wrong with my code, normally. So I then also now and then use one called leave, and just before it actually exits and go back to the JVM, I just say, I'm kind of finished now. So I define these kind of macros, and then my log file will look something like that. I would just log values and so on, and I can actually kind of see what happens in my C++ code. Since we are in two different worlds, profiling and debugging, as I said, is really hard. Of course, you can do some kind of, the debug class has the start method trace and provides you something, not very good. There is a project that tries to support the GNU profiler, but it will only work for some architectures, not very good. Valgrind has some support for Android in recent versions, actually version 3, which is the recent version. So you can actually find your memory leaks, which can be very useful. NVIDIA provides a debugger for their platform only, of course. So if you're not using their platform for your Android development, you're kind of out of luck there. If you want on a simulator, you cannot use that, and so on. So profiling and debugging is really hard. That's why I always use these traces. If you just use the normal, this NDK section in your Gradle, the library, the SO files that is the end of the compilation are really big. And you want to reduce the size, so you really want to use link time optimizations, and you want to eliminate unused code, and you want to optimize for speed, or for space, and all these kind of things. And if you want to do that, you have to write your own Gradle scripts, basically. The good thing is that you can find a recipe. I linked to a recipe that actually we were able to reduce at RAM. We were able to reduce with, was it 80%? We could reduce the size of our library size, which was kind of nice by using these tricks. I just have a few references. As you can see, JNI stuff isn't new. It's from the last millennium. There's coming out a book very soon, I think. It's planned this year about Android performance. Has nothing to do with C++ code. From the few chapters I have been given access to so far. There's also one about Android NDK, and it's primarily about game programming, I would say, because they use it a lot.